Right now, as you are watching this, it is exactly 16 years to the day since the largest hailstone ever measured on Earth fell out of a collapsing storm system in Vivian, South Dakota. A chunk of ice 8 inches across and nearly 2 pounds in weight. And this week, the same basic recipe that produced it is showing up again. In Connecticut, meteorologists are still working through this verification process on a baseball-sized hailstone that fell as this month's brutal heat wave finally broke. A stone that could end up as the largest ever officially confirmed in that state's history. In Alberta, Canada, a research group recovered a hailstone weighing nearly 293 grams, enough to break the Canadian national record that had stood since 1973. In Texas, a stone measuring just over 7 inches across, found lying in a roadside ditch by a storm chaser who initially mistook it for a discarded jug, was only officially certified as that state's record earlier this year, nearly 2 full years after it actually fell. Every one of these records shares the same origin story. A heat wave building enormous stores of atmospheric energy, and then collapsing all at once into exactly the kind of violent storm that can grow ice the size of a fist. This is the story of why heat waves do not just end quietly, why their collapse is often the single most dangerous part of the entire event, and why the record books keep getting rewritten by storms. Nobody was specifically watching for hail that day. No hype, no filler, just what the data and the storm reports actually show. Drop a comment and tell me if you have ever seen hail like this where you live. I read every one. If you want weather coverage that explains the mechanism instead of just showing you a dented car hood, subscribe. It costs nothing. And a like helps this reach people who need to understand what a breaking heat wave can actually produce. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand why a heat wave's collapse is more dangerous than the heat itself, you need to understand what a hailstone actually is and how it grows, because it is a genuinely strange process. A hailstone starts as a tiny ice pellet, often forming around a speck of dust, high inside a thunderstorm where temperatures sit well below freezing even in the middle of summer. The pellet only grows large if it gets caught inside a powerful updraft, a column of rising air, strong enough to carry it back up through layers of supercooled water droplets, water that stays liquid even below freezing until it touches something solid, at which point it instantly freezes onto the hailstone's surface in another thin layer. The stone keeps growing exactly as long as the updraft keeps winning the battle against gravity, and it only falls to the ground once it becomes too heavy for the updraft to support any longer. This means tread out of how powerful that storm's updraft actually was, and updrafts do not get more powerful than the ones fed by a heat wave's own stored energy being released all at once. That is precisely the mechanism behind Connecticut's own record attempt. The heat wave that had been baking the Northeast through the beginning of July finally broke on the 4th, when a complex of storms moved through the southern half of southern New England. A National Weather Service meteorologist described it afterward as a few supercell-looking storms, followed by a strong line packing significant wind damage, and reports from Bristol, Plainville, and New Britain measured hail up to 3 inches across baseball-sized stones capable of denting cars and shattering skylights. More than 100,000 customers lost. Power across the state. Wind gusts reached the 65-mile-per-hour range, and one storm assessment for the wider region. Recorded gusts of 87 miles per hour in Suffolk County, New York, and 81 miles per hour in Carroll County, Maryland, on the very same system. A utility company serving roughly 1.5 million customers across 29 Pennsylvania counties later ranked the event among the 10 most significant storms in its entire operating history. As of this week, the 3-inch Connecticut stone is still working through the kind of formal verification process that state climate offices use before a record becomes official, comparing photographs, measurements, and eyewitness accounts the same way Texas's own Climate Extremes Committee did with its record stone. That Texas comparison is worth sitting with because it shows just how long these verifications can actually take and how easily a record-breaking hailstone can nearly get missed entirely. Back on June 2nd of 2024, a storm chaser working a tornadic supercell near Vigo Park in the Texas Panhandle spotted what he thought at first was a discarded gallon jug lying in a roadside ditch. It turned out to be a hailstone measuring 7.1 inches in diameter, wider than a regulation-sized football, produced by a supercell thunderstorm that had developed in conditions specifically primed for giant hail growth. It took the State Climate Extremes Committee, made up of representatives from the National Weather Service, NOAA, and the State Climatologist's Office, until April of this year, nearly 2 full years later, to unanimously certify the stone as Texas's new state record, beating the previous mark of 6.5 inches set in Hondo back in 2021. The delay was not laziness. It reflected how much careful cross-checking goes into confirming a record that will stand as an official reference point for decades, comparing photographs against known objects for scale, cross-referencing radar data from the exact storm that produced it, and interviewing the people who found it before a committee will put its name behind a number. The same pattern played out north of the border. A hailstone recovered near Markerville, Alberta, weighing 292.71 grams and measuring 123 millimeters across, was confirmed by researchers at a university-backed hail tracking group as Canada's new national record, surpassing a stone collected in Cédaux, Saskatchewan, all the way back in 1973 that had weighed 290 grams. The group's field director described finding a hailstone that size as like hitting the jackpot, noting that only 22 stones in the entire world database have ever weighed more than 290 grams. A database that researchers say helps them refine estimates of just how large hail is physically capable of growing before gravity finally wins. It is worth putting the Vivian, South Dakota stone itself in context here too, since it remains the benchmark against which every one of this year's near misses gets measured. That hailstone recovered on July 20. 3rd of 2010, measured 8 inches in diameter and weighed 1.94 pounds. So large that the people who found it initially had no real name for it beyond comparing it to a pineapple or a monster, and it still holds both the United States size record and the North American weight record today, 16 years and counting. Meteorologists who study these extremes point out that the theoretical ceiling on hail size is not infinite. It is bounded by exactly how strong a thunderstorm's updraft can physically get before the storm itself tears apart, which is part of why events at or near that ceiling remain vanishingly rare even during an active, severe weather year like this one. All three of these near-record or confirmed record events trace back to the exact same atmospheric setup, and it is a pattern that kept repeating across the American heartland all month. Not as isolated one-off storms, but as an almost weekly occurrence. In early July, severe thunderstorms swept the Central Plains and Upper Midwest, bringing threats of large hail and flash flooding across Montana, Wyoming, South Dakota, Colorado, Nebraska, Kansas, Iowa, Wisconsin, and Michigan in a single outbreak. Days later, the threat shifted specifically toward Colorado's Front Range and Eastern Plains, where forecasters warned of golf ball-sized hail in Phillips, Logan, Washington, and Yuma counties. And a tornado was confirmed in eastern Wyoming alongside wind gusts as high as 113 miles per hour near Akron, Colorado. Later still, meteorologists in Denver issued a blunt public warning to keep vehicles in the garage overnight as storms capable of producing hail 2 to 3 inches in diameter moved along the Interstate 25 corridor and out onto the eastern plains. Part of a stretch where forecasters said severe storms were likely to redevelop day after day rather than arriving as one single event, with hot, humid air pushing north from the Gulf providing the moisture while fast winds aloft supplied the spin needed to organize ordinary clouds into rotating supercells. Every one of these outbreaks followed the same underlying script, a heat dome building extreme instability near the surface, then a disturbance finally arriving to break that heat down all at once. And that collision, hot moist air below meeting a disruptive push from above, is exactly the combination that builds the kind of towering, long-lived supercell thunderstorms capable of growing hail into something that ends up in a record book instead of just a storm report. There is a reason this keeps catching people off guard, and it comes down to where public attention naturally goes during a heat wave. Almost all of the warnings, the news coverage, and the personal caution during a multi-day heat dome focus on the heat itself, staying hydrated, checking on elderly neighbors, avoiding outdoor exertion during peak afternoon hours. That attention is entirely justified. Heat kills more people in an average year than almost any other weather hazard. But it means the moment the heat wave actually breaks, the moment that brings genuine relief from the temperatures, is frequently the same moment the atmosphere unloads all of that stored energy in a single, violent burst. And by then, most people have mentally already moved on from severe weather anxiety to relief that the hot spell is finally over. The National Weather Service's own guidance around the 4th of July storms noted this directly, describing how a frontal system pushing into then stalling across a region gradually brings relief from the heat while simultaneously providing a focal point for torrential rainfall and, in this case, damaging hail and destructive winds. All arriving in the same window, meteorologists were mostly describing publicly as good news. So what does this actually mean for you the next time a heat wave you are living through finally starts to break? The instinct to relax once temperatures start dropping is understandable, but is exactly the wrong moment to stop paying attention to the forecast. The specific window when a stalled heat dome finally gets pushed out by an approaching front or trough is statistically one of the more dangerous stretches of the entire event, not the safest. Precisely because it is when all the heat and humidity that built up over the preceding days gets converted into updraft energy. Treating the arrival of storms at the tail end of a heat wave with the same seriousness as the heat itself, moving vehicles under cover when hail is in the forecast, having a plan for sudden power outages, and not assuming across every single event described here. It is also worth remembering that hail this size does not need to set an official record to be genuinely dangerous. 3-inch stones falling at their terminal speed can shatter windshields, cave in roofing, and injure anyone caught outdoors without shelter, regardless of whether a state climate committee ever certifies the exact measurement. To bring this together, the largest hailstone ever recorded fell from a collapsing storm system in Vivian, South Dakota, exactly 16 years ago today, and the same. Mechanism, a heat wave's stored energy unloading all at once into a powerful, sustained updraft, has been rewriting the record books all over again this year. Connecticut's own baseball-sized hailstone from the 4th of July heat wave breakdown is still awaiting formal verification as a potential new state record, following the same process that took nearly 2 years to confirm Texas's 7.1-inch record stone from 2024, and that recently confirmed Alberta's new 293-gram Canadian record. Across the plains, in the Front Range, the same pattern of heat-building instability and then collapsing into severe hail-producing storms repeated week after week throughout July. A reminder that the most dangerous part of a heat wave is very often not the heat itself, but the moment it finally violently breaks, and that the record books tracking these storms are being rewritten far more often and far more quietly than most people watching a heat wave finally end would ever assume. We are going to keep tracking this the same way we did today, straight from the National Weather Service, state climate extremes, committees, and the researchers actually out in the field measuring these stones, not a single viral photo treated as the whole story. Subscribe if you want to know the moment Connecticut's hailstone gets its official ruling, because based on how this year has gone, it likely will not be the last record this pattern produces. And leave that comment below, tell me where you're watching from, and whether your own local heat wave has broken yet. 5,000 likes on this one. Let us go. See you in the next one.